Okay, I just wanted to work a quick linear programming example with you. If you'll remember, the first step is to define our variables. So let's read the problem. Dean Stadler has 20 days in which to plant corn and soybeans. The corn can be planted at a rate of 250 acres per day, and the soybeans at a rate of 200 acres per day. He has 4,500 acres available for planting these two crops. Okay, so our first question is always going to be, or our first task is always to define the variables. Hopefully you'll recognize that the two questions we need to answer is how many acres of corn are we going to plant and how many acres of soybean. So the obvious choices here for variables are going to be C for corn, the number of acres of corn, and S for soybeans, the number of acres of soybeans. Okay, and often we point out the very obvious to begin with, and namely, we cannot plant less than 0 acres of corn, or he cannot, and he cannot plant less than 0 acres of soybeans. Okay, and now we have to go to the problem to find more information. All right, so it says he has 20 days to plant and 4,500 acres available. Those are the two constraints. The first one being how much time he has, and the second one being how much land he has. How much land he has is a much easier question to deal with. So let's write that down first. So we've got the land constraint, right? I mean, if he wanted to make a lot of money, why didn't he just plant 1,000,000 acres of corn and 1,000,000 acres of soybeans? Obviously he can't. So I want to talk about how much land it takes. Well, if he plants C acres of corn, then that's going to take C acres. And if he plants S acres of soybeans, that's going to take S acres. So when I add the number of acres of corn plus the number of acres of soybeans, the number I get has to be less than or equal to 4,500. Okay? And then the other one, and this is considerably more difficult, is the question of time. How much time is he going to spend planting corn? How much time is he going to spend planting soybeans? So I'm going to write the plus sign between them. So how much time he spends planting corn plus how much time he spends planting soybeans, that has to be less than or equal to 20 days. Now, let's discuss how long it's going to take him to plant corn. I'm going to pick acres of corn that makes it easy to work with, and then I'm going to figure out how many days it takes to plant that. Okay, so if he planted no corn, it would obviously take 0 days. Let's see, 250 acres per day. Well, let's see. What if he planted 250 acres of corn? Clearly that would take 1 day. What about 500 acres of corn? 2 days. 750 acres of corn would take 3 days. Okay. I hope you can see there's a pattern here. And what I want you to ask yourself is, how do I get from column C, the number of acres of corn, to the number of days that it takes? Obviously, we know it's related to 250. Let's see if you can see what he does. Okay, I hope you can see that what is happening is you have to take the number of acres of corn and divide it by 250. So if he's going to plant C acres, if he's going to plant C acres of corn, then the amount of time that takes is going to be C divided by 250. Okay, so that's what I'm going to place over here as the amount of time that it takes to plant the corn. I'm going to assume that you can, if you understand this, you can make the jump to soybeans. It's going to be very similar. It's going to be the number of acres on top, S, and this time, instead of dividing by 250, I'm going to divide by the rate for soybean, which is 200 acres per day. Okay, we have our constraints now. Okay, and now we need to graph this. As we're used to, these two constraints tell us that we're only working in the first quadrant, so let's mark this off. I'm not going to put any numbers up there until I get my intercepts up there, because it turns out we're going to have our intercept's going to be quite large. Okay, so first, let's do the easy one. The land constraint. Okay, so what I want to consider is, I should label our axes. C will be the amount of corn, and soybeans will be the vertical axis. Okay, now let's talk about land. If all I planted was corn, 0 acres of soybean, I'm going to cover up, and let me get up. Okay, so we're going to graph these by intercepts. This isn't going to work perfectly, but it should work well enough. Okay, land. I want to consider the C-intercept, which is to say if I plant no soybeans, how many acres of corn can I plant? So I cover up the soybeans, and I have C equals 4,500. So that's going to be my intercept over here, 4,500 acres. 4,500 and 0 acres of soybeans. Similarly, if I want to see how many acres of soybeans, I cover up the corn, and again, that's going to be 4,500 acres of soybeans. So 0 acres of corn, 4,500 acres of soybeans. Okay, we'll just leave that there. Now we need to consider the more difficult question of how much can I plant if I only plant corn. As far as time, I have to consider this constraint as well. So first I want to know how much corn can I plant. So what I do is I cover up the soybeans, and then I have C over 250 equals 20. So to solve for C, I need to multiply by 250, and I get 1,000 times 5,000 acres. So theoretically, if I had all the land I wanted, I would only have enough time to plant 5,000 acres. So I need to change pins here. 5,000 acres. I'm not doing this to scale, but I don't really need to. I just need to get it on the right side of the other intercept. And then what about if I only planted soybeans? How much could I plant? Again, not considering the constraint on how many acres I have. Just I've got 20 days, and if I can plant 200 a day, I'm going to multiply by 200, and I get 4,000 acres. 4,000 acres. So I'm going to point out here that if Mr. Stadler only plants soybeans, he's not going to be able to plot all of his, he's not going to be able to fill all of his acreage. I forgot to connect these dots earlier. Obviously, in both of these cases, we're going to shade beneath the line. Okay, and so I didn't bother shading earlier, and that's simply because I didn't want to confuse myself. I'm just going to shade the feasible region, which is this right here. Okay, we're going to find the vertices of the feasible region. Some of them are obvious. I've already marked 4,500, 0. I've already marked 0, 4,000. This is obvious, 0, 0. The origin's always very simple. And then I need to find where these lines cross. Where the blue line and the red line cross. I'm going to need to go onto a separate page to do that. So insert, blank page. And I'm just worried about the boundary lines, not the inequality. So I have C plus S equals 4,500. And then I also have C over 250 plus S over 200 is equal to 20, the number of days. So I'm going to use substitution or elimination, but first I want to get rid of these denominators. They're quite gross. And what I need is a number that they both go into, so I can multiply by that. I see that 50 goes into both of them. It looks like they both go into 1,000. If you think of it, you could just count by 250 until you get to a number that 200 goes into. 750, no. 1,000, yes. That's the least common multiple. They both go into 1,000. So I'm going to multiply everybody in the second equation by 1,000. Both sides times 1,000. Okay, and that simplifies. So 1,000 divided by 250 is 4C plus 1,000 divided by 200, it's going to leave me with 5S equals 20,000. Okay, and what I'm going to do is I'm going to eliminate the C's. So what I'm going to do is take this equation, and I'm going to move it down here, but I'm going to multiply it by -4. multiply everything times negative 4. So positive 1c is going to become negative 4c. Positive 1s is going to become negative 4s. And positive 4,500 is going to become negative 18,000. I'm going to add these up. The c's are eliminated. 5s minus 4s is 1s. 20,000 minus 18,000 is 2,000. So I've got s equals 2,000. If I want to find out c, I'm just going to plug it into this original equation. C plus s equals 4,500. And then subtract 2,000 from both sides. So it looks like my final vertex is 2,500 for C and 2,000 for S. 2,500 for C and 2,000 for S. I have my vertices. Okay, I do not have a function to maximize or minimize, so I'm going to have to get that information from the book. All right, so number 40 tells me prices. I'm going to need a profit function. It depends on how many acres of corn and how many acres of soybeans. In this case, for every 1 acre of corn, I'm going to earn $26. So I'm going to make 26 times C on corn. I'm going to make 30 times S on soybeans. My options are 0, 0. Of course, I'd make $0. 0 acres of corn and 4,000 acres of soybeans, in which case we'd make $120,000. Okay. If I planted all corn, I could get all 4,500 acres planted. 45, it's $117,000. And then finally, if I plant 2,500 acres of corn, and 2,000 acres of soybeans, I'm going to make, let's see, 2,500 times 26 plus 2,000 times 30, and that's $125,000. So in this case, it appears that the maximum amount of money is going to be if Mr. Stadler plants 2,500 acres of corn and 2,000 of soybeans. Now, they switch it up just a little bit in number 41, or 40, or whatever. Yeah, this is 41. Because they changed the prices. So the function's slightly different. It still depends on corn and soybeans, but this time it's 29C plus 24S. In this case, we're going to run all the possibilities. 0, 0 is still going to earn me no money. You have to plant, okay, if I plant just soybeans, 4,000 times 24 is $96,000. If I plant just corn, that's 4,500 times 29, 130,500. Or if I go for the point where it's 2,500 acres of corn and 2,000 acres of soybeans, that's going to be 2,500 times 29 plus 2,000 times 24, total $120,500. So in this case, it seems like the answer is that we need to plant nothing but corn. Corn is up, soybeans are down, so we're going to plant